In this video, I'm going to be doing a quick explanation of limits at infinity. So when we talk about limits at infinity, what we mean is, what is the limit of a function as x approaches infinity? Which we would write something like this: the limit of a function f of x as x approaches infinity. Well, we have to know whether it's positive infinity or negative infinity, and that would be equal to something, or the limit of a function as x approaches negative infinity is going to be equal to something. So let's talk about what that means. So if we have a graph, we have a y-axis, and we have an x-axis. Excellent little graph I have here. All right, so on the x-axis, we know that the x values get larger and larger as we go to the right. So we go from 1 to 2 to 3 to 4, and the little arrow at the end means that we go on forever and ever. In other words, the x values are getting infinitely large. So over here we have x is going towards positive infinity. Well, the same thing on the negative x-axis. We're getting infinitely small. The numbers are going towards negative infinity. So over here we have x equals negative infinity. So when I talk about what is the function doing as x approaches positive infinity, what I mean is what is happening as we go infinitely far to the right on the graph. And if we want to find the limit of the function as x approaches negative infinity, we're looking what is happening infinitely far to the left. Okay. Now the answer to that is going to be usually plus or minus infinity. To understand that, let's take a look what's happening on the y-axis. So we know that y goes up and it gets infinitely large. Because of this little arrow, it's getting infinitely large. So y is equal to positive infinity up here. The y values, or the function values, are getting infinitely large in a positive direction. And down here, the y values are getting infinitely small. So y is approaching negative infinity. So let's take a look at an example, make some sense out of all of this. Let's just do a simple graph. Let's say we have a line, and that line is our function, and let's just make that a straight line. And this is the function f of x. Those are supposed to be little arrows out there. There we go. Yeah, my little arrows. So we want to know what is the limit of this function f of x as x gets infinitely large. All right, so as x gets infinitely large, we're looking what is happening to this function as we go out infinitely far in this direction on the x-axis. Well, as we go infinitely far on the x-axis, okay, we're getting further and further. This goes infinitely far. What is happening to the y value? Well, the y value is going up, and it's going up. And we know that lines never change direction. So as x is getting infinitely large, the y value is getting infinitely large. And remember that our limit is really what the y value is approaching. So the y value is approaching positive infinity. Well, likewise, we could find the limit of this function as x approaches an infinitely small number. So now we're looking over here. We're going in the negative direction. As x is getting smaller and smaller and smaller and smaller and smaller, the y value is getting smaller and smaller and smaller and smaller. So the y value is approaching negative infinity, and that's what our limit is. The limit is what is the y value or the function value approaching as x approaches something. Well, as x gets infinitely small, y is getting infinitely small. All right, let's do one that's just slightly different. Let's do a parabola. So make a quick set of axes here. Now we know that a parabola looks something, here's a downturning parabola. So by just looking at the graph, if you understand the concept, you should be able to determine what the limits at infinity are. The limit of the function as x approaches positive infinity, in other words, we're going out in this direction, what's happening to the graph? Well, the graph is going down and down and down and down, and it's just going to keep going down forever. So the limit of the function as x approaches positive infinity is negative infinity. The y values are getting infinitely small. And same thing over on the other side, the limit of the function as x is getting infinitely small, going towards negative infinity. Well, over here, the graph is also going down and down. The further we go out to the left, this is going to keep going down and down and down and down. So the limit as x approaches negative infinity is also negative infinity. Now, the limits are not always going to be infinity. Here's an example. If we have a horizontal asymptote, so here's my axes, and I have a horizontal asymptote. Remember, a horizontal asymptote is some line, a horizontal line, that the graph will never cross. And let's just say that this is the line y equals 2. And it also goes in both directions infinitely far. And let's say we have a graph that looks like this. It's going down here, and it's coming up. Now, it can't cross this line, so it's going to come infinitely close to it. Infinitely close, forever and ever. So what would be the limit of the function f of x? Once again, this is the function f of x. As x is getting infinitely large. So as we go out in this direction on the x-axis, no matter how far out we go, this function is getting infinitely close to a y value of 2. It will never touch 2, but it's becoming infinitely close to 2. And remember, that's the idea of a limit. As x approaches something, what is the y value approaching? Well, the y value is approaching the horizontal asymptote 2. And in the other direction, the limit of the function as x approaches negative infinity, that would be out in the other direction. What's happening out here? Well, it's going down infinitely far. So this limit is simply negative infinity. And let's do one that has a couple of asymptotes. You never know when you might have one graph that has two asymptotes. So here's one asymptote. Here's another asymptote. Both horizontal asymptotes. And this is the line y equals 8. And this is the line y equals negative 3. And the graph does something like this. It comes out over here, goes down, goes up, goes down like this. Now, from the best that we can tell, this would be a very weird graph, by the way. I just made this up. From the best that we can tell, as x is getting infinitely large, this graph is getting infinitely close to that line. So the limit of this function, as x is approaching positive infinity, it looks like this is getting closer and closer and closer to the asymptote of negative 3. And over here, the limit of f of x, as x is approaching negative infinity, it looks like we're approaching the asymptote y equals 8. So the y value is getting closer to 8. One last quick example. We have to remember with limits at infinity is we don't care what the graph is doing. except at infinity. So what if we had a vertical asymptote? See, there's a vertical asymptote right here. And so we have a graph that looks like this. It's going like, oh, I don't know, like this. And then it's going like this. All right, all we're looking at is what's happening out here and what's happening out here. And put my little arrow on the end there. So it appears that the limit of this function, as x is getting infinitely large, is approaching the x-axis. This is the x-axis. So that is a y value of 0. The x-axis represents where y is equal to 0. So as x is getting infinitely large, the y value, or the limit, is approaching 0. Likewise, the limit of the function, as x is approaching negative infinity, is also 0. The graph is approaching 0 out here too. And so both of our limits are equal to 0. That's a limit at infinity. Hope you found this helpful.